In this video, we are working on the first question, but we're dealing with that sketch over there. It's clearly a proportionality theorem kind of question. We are given the sketch, and they have told us two ratios or two sets of ratios. They told us that AM, or rather the ratio between AM and MC is 10 to 23. That is interesting. Furthermore, they told us that the ratio between AK and KB is 3 to 2. Yeah, that is quite interesting. Like, oh my goodness, that's like so much information. But it is what it is. I feel like we're gonna have to draw this a bit bigger because it's like, it's a bit small over there, and it's like, I watch you. Anyways, let's put this information on our sketch. So anytime you're given ratios, right, you want to work with ratios as though you are dealing with like a grade or 8 or 7 kind of math question, and you'll see what I mean just now. From what they told us that the ratio AM to MC is 10 to 23. So what that means is this and this is just 10 to 23. You may want to put like an X here and an X over there to show that these are not like lengths of the lines. It's just a ratio. Let me put it this way. I mean, like ratio 1 to 2 means that for every one of this, you'll have double that one, you see. So for every 10 of these, you'll just have to have 23 of those ones. Yeah. But anyways, the other thing that they told us is that AK to KB, the ratio there is AK to KB, the ratio there is 3 to 2. You see, meaning every time you have 3 of these, you need to have 2 of those. But then because there's a ratio there and it's not like the lengths of the lines, you need to put like a variable there, we can make it a y, and a variable there, we can make it a y. Okay, so the way this is set up, obviously, like to the eyes, sometimes it's like, oh goodness, not that thing again. We're gonna explain it. Hold on. Just hold on tight. Do not panic. So if you're going to work out the ratio AN to AM, if you look nicely, right, the ratio AN to AM is purely based on where these parallel lines are going. You see, because if you are new to the proportionality theorem, this is one thing I can say up front. When you're going to be working with the proportionality theorem, right, focus on where the parallel lines are. If you can focus on where the parallel lines are, and if you can focus on getting an image that looks something like this, then you're set. You know, whether it looks something like this, or it looks something like this, or it looks something like this. You see, it doesn't matter. Just try and focus on an image that looks something like this, and then you're set. This is what I mean. With this whole sketch, right, just like all Euclidean geometry questions, don't focus on the whole image, you know, all the time. No, sometimes you just need like a small portion of the image. So for example, if they're talking of the ratio AN to AM, I mean, like, you literally just need this small portion of the sketch. Let me draw that small portion. There's B here, there's M down there, and then there's A here. There you go. Now what you know is that this is N, right? They're looking for the ratio AN to AM. Now, just by looking at this image, like, this is screaming proportionality theorem, because you can always use your proportionality theorem laws whenever you have an image that looks something like this. Now, the fortunate thing is, based on our bigger picture, this whole thing here is representing 10x. And then this tiny part here is representing 3y. And this tiny part here is representing 2y. You see, like, just follow along for a bit. So what they want us to do is to write out a ratio AN over AM. Before we can write out a ratio for that, let us just write out an expression that is also equal to AN over AM. And this is what we mean by that. So if you look at where AN and AM is, we know that according to the proportionality theorem, AN over AM, we know that it is going to be equal to AK over AB, because the motion that is going to happen here is the same there. What I mean is what you write out needs to match. You see here we wrote out AN, and then for the other side we wrote out AK. And then down here there is AM, which stretches over 2 lines, and then down here we have AB, which stretches over 2 lines, you see. So we have written that these are equal to each other. The reason is the proportionality theorem. After you have done that, this is where things get super duper easy, because like, why not, you know? AN over AM is equal to AK over AB. So we already know that AK is being represented by 3y, AB is being represented by the whole thing. Obviously, if this small part is 3y and this small part is 3y, it just means the whole thing is like 5y. And then the y's cancel out. And then this is your ratio, 3 to 5. Voila. And then is done. The next question is asking us for this ratio, CL over LK. So that's going to be interesting, and that's going to be in the next video. So if this was helpful, don't forget to like, share, and subscribe. Like, share, and subscribe. Why would you be sharing though? Well, the big idea is if you're like gonna do well this year, you may want to plug your people, you know, so that you can like get distinctions as a squad. It's just the way to do it, man. Like, don't be that person, you know, like share the knowledge. But anyways, yeah, that is that from my side. I will catch you in the next video.